Currently, the new assembly workbench of FreeCAD 1.0 version does not have a tool for sliding in a slot. The dedicated sliding joint allows movement between like-minded surfaces only. It will allow joint between a cylinder and a tube, between two planar surfaces, or between two straight lines. While this tool makes those sliding movement easy to build, this does not allocate sliding in a slot. In reality, sliding movement within the confines of a slot is a very common mechanical movement. In last week's video, I described a workaround where I was able to construct a slot slider using other tools available in this assembly workbench. Today I want to use that principle to build this model where a sliding slot facilitates and regulates the reciprocating movement of a straight member as seen in this model. If you have not already watched my last week's video, I invite you to take a look at that. That way both you and I will be on the same page going forward. With that, let's get started. Today I am using FreeCAD version 1 release candidate 2, and I have my last week's model loaded here. So I will be reusing this vertical bar and this horizontal model bar in this model's build. So let's open up a new file and start building that two vertical and horizontal bars real quick. So let's do with vertical bar first. I used a slot in the middle and another slot on the outside, two rectangles on each side, so this is the basic of that sketch, and do some clearing in here, and that becomes this. So this is the sketch. Let's go ahead and extrude that for say 45 millimeter in symmetric fashion there. And I want to use that same sketch on this way from this side. So let's start with another sketch on YZ plane, and then I want to clone this sketch. Now because this is not on the same working plane, we will have to press Ctrl and Alt. So use this button. This is says create carbon copy. Select that, and then before clicking onto this sketch, right, hit Ctrl and Alt, and then now I can select this. So that pulls in that sketch in here. Now close it up. So we have that sketch in the middle. I want to extrude that for 45 millimeter symmetric as well. So we can do that, or better yet, what we can do, we can take this one and create a clone from draft workbench. You go to draft, and then there is this clone. I have that on my shortcut. So we can create a clone and then transform that 90 degrees, and that gives us the same result. Now we can go ahead and take these two, and in part workbench we can make a common intersection. So that is that simple. That's our vertical member, which has a slot in this direction and another slot in this direction. All right, let's go ahead and allocate a support system in here. So that will be pretty easy on YZ plane, or maybe on the XZ plane. All right, so on XZ plane I want to draw a sketch of two circles and trying to match these actually. So maybe I want to take this point as a reference and then make them in same horizontal plane, and make this one say 10 millimeter diameter, this one 20 millimeter diameter. So that's a fully constrained sketch, and I can extrude that now for 20 millimeter symmetric. Now I can take these two parts and make a connect. So that's a join object. I want to do the connect, and that combines these two. So this hole will allow the support there. We will be making that support very rudimentary, but this is our pendulum, right? Okay. And now on the horizontal bar, so this horizontal bar on this model is very simple, and maybe I will take help from, so take this sketch, and so that way it's quicker. And here I'm gonna paste it here, and there it is. So it's a simple sketch that has a hole in the middle, and maybe we don't need these ends in here. Rather, I'll just close it out just like that. So that's a rectangular area that has middle two holes in there. And all right, we'll have to make this one horizontal, and then what else? Maybe put in a length. So let's say I want to make this total length of 150 millimeter. So that's a fully constrained sketch. By the way, I'm using a new theme, and that's why this outlook is kind of like changed. I like it. All right, and now I can go ahead and extrude that for 20 millimeter, make it symmetric, and hit apply, close there. So we have this bar. It looks weird, it's a little skinny. Maybe I'll go ahead and update this 10 to 15. Let's see how it look. Yes, much better. So we have this one. Now we'll have to have that support and support here, so that will be easy. So we have both of our two main parts, and here comes the principle that we talked about in the previous model. Here what we have is a cylindrical part in the middle that allows rotation in there, and then two end parts that has movement for the slotted area. So we will use the same model here because that's the main part of this video. I'm gonna go ahead and spend some time in building that part and maybe do some trick in there. So what I want to do, I want to get in with a cylinder. There is that, and I think this is radius 20, this is radius 10, diameter 20. I'll make this radius 10 as well, and then maybe lay it flat this way. Yes, and bring it over here, something like that. So I'm assuming you watched my last video, so you know that I created a rectangular part here to make this face parallel to that. We will be doing the same thing today, but I want to make it look good. So maybe take this cylinder, make it aligned with this face. So if this is a 10 millimeter wide, I want to go in the placement on Y, make this minus 10. So now it is facing, it's like it's on the same face. All right, what I want to do, I want to take this cylinder and then mirror it over on the other side, so that would be against Y X Z plane, right? And there, now we have that two parts in there. Okay, maybe I want to make this height as 15. Oh, not that one. This height as 15 and make this as -5. What do we have? So we have tiny little gap in here, and in there what I want to do, I want to draw a sketch on XZ plane, on that plane, And then now I want to draw a centered rectangle right there. So this is going to be 20 on both sides. I want to make these two equal. Right. So we have that sketch in the middle, and I think this is 5 millimeter, that is 5 millimeters. So I can go ahead and extrude this sketch for 10 millimeters symmetric, and that fills in that gap. So in the previous model, I had this circular part in the middle and then two edges on the outside to explain the theory. Now what I can do is I can hide that part in the middle, so people will think it's not there. So let's go ahead and make these three one piece. So union, that gives us this fusion, and let's rename that as the pivot. And then this is the horizontal bar, so actuator. Okay, so we have the pendulum, we have the actuator, we have the pivot in there. Now all I need is the support system. So we'll have to create a support in there. Let's do that. I want to create that support in place. So this is going to be radius, I think diameter 10, and then this length, this point will be at 150 millimeter. Right, and there is that sketch right there. I want to extrude that for 20 millimeter symmetric. So we have the support there, and then we'll have to work on the support in this side. So what I want to do is I want to work on this side, the YZ plane. Okay, so on YZ I want to offset and offset it, say for example 50 millimeter for now. We'll explain that in a minute. And I want to take this line as my reference. Okay, so this support is simple. We are just making something, just a simple thing. There, that is my support. All right, I have it here. I'll probably have to move it somewhere here. So what I want to do, remember that offset that I did 50 millimeter. Maybe I want to make that 100. There. And now I can extrude that for say 10 millimeter, doesn't matter that much. So that is my support, right? And what if I wanted to mirror it over on the other side, YZ plane? Pretty cool. So that is my support system. What I'm going to do is I'm going to take this one, and this one, and put them together, and that is my support. Since they are built in place, it will be easy for me to apply that in there. So we have everything we need for this model. Let's start putting them together. So we start with an assembly and then start adding. So I will be adding, so this is my file. Maybe I want to save it first. All right, now I want to add, so this is my file. I want to add the support first. Because I have this setting that says anything I first add into the assembly will be grounded, means fixed in place. So I have that in there, so it's not going anywhere. Now I can add the pendulum, but so the pendulum is not grounded. Now I can go ahead and apply a revolute joint between this pendulum. So I want to select this cylinder and that cylinder in the middle, that places in their mating in the mid surface. Hit OK. So now the pendulum will go back and forth, and that's what we need. We will have to probably update this sketch, this location. We'll have to update it that way. to modify this slot length. All right, and now I want to add the horizontal bar. So that's the actuator here, right? And the actuator will go back and forth through this slot, right? So now it is moving freely. We want to fix it in there. So first thing first, I want to define the parallel planes. We want to say this plane will be parallel to this plane, right? So now that is one way to say this is not going to kind of twist. So you cannot twist it in there. It will, whatever it is, it will be parallel. And then I want to say the distance between this plane and this plane will be 0. All right. So now it's not going up anymore. It's going sideways. All right. Now we can say this distance between this plane and this plane will be 0 as well. All right. So that is fixed. It's fixed right there. It's now sliding. So that's another way to make a sliding joint when we have all orthogonal surfaces. Very simple. So this sliding, we could use that one too, but this is easier to me. All right, and now think about it. So we have this lower surface 0 and this surface is 0 too. If we flip this object this way, right, it's not flipping now, but if we flipped it, it would be still valid, these two conditions, that it can be flipped 180 degrees and still it will be valid, these two conditions. So what I want to do is I want to take this surface and take that inner surface and make that distance 0 as well. So it may appear that is an over constraint, but it is not. It will just stabilize this model when it's needed. Okay, so we have everything in place. So here is this one goes up and down and this goes left and right as well. Let's set up the pivot. So the pivot we added last time is different than this one. Last one, the cylindrical part was in the middle, so it was easy to add. Now this one we'll have to do some calculations. So this line, this length is 20 millimeter wide, and we have this one as 10 millimeter wide. So when we add this surface basing on these two circles, it will still have to be moved inside for 5 millimeter. So let's do that. I want to add a revolute joint between this surface and I'm going to say this surface. So that kind of adds in there. All right. So it is mating in there and I want to offset it for 5 millimeter inside. Now, because that rectangular part is inside there, we don't see that, but we are not adding that property in this joint. The property that we added was the rectangle, this revolute, so it is still freely moving, which is, so to speak, is not practical, but we're just doing that so people like from outside it thinks like it's not there. Kind of deceiving, but you have to do what you have to do. All right, so we got that. Now that part is going back and forth with our actuator. Very good. All right, now the hard part is to take that square surface, that's perpendicular surfaces, and then match it with this one. I can do that by hiding this actuator for now and take this surface and this surface, make them parallel. All right. Now whatever this one moves left and right, that actuator will be rotating its position to match with it as well. Okay, and then finally, this is the final task. We take this surface and take this surface and make a distance of 0 millimeter, because this fits in perfectly in there. This will do. Okay, so there is that. It's moving up and down, you can see. So it's coming here and it's going there, kind of acting as this. So this would also apply that what we said, it is 0 from this surface. What if this part flipped over on the other side in extreme cases? That would kind of like mess up the model. So what I'm gonna do, although it seems like an extra or like redundant, I'm just gonna make this 1 0 as well. That way there is no chance of flipping it around. All right, time to bring our actuator back, and here is the moment of truth. See, there it is. All right, it's working fine. Here is, my friend, the mechanical movement 101 as shown in that model, working perfectly. So now we can see that this actuator is coming out of this just like that. We can limit that. We can make that say we don't want this to cross this part, right? So we can do that easily. What we'll have to do is we can do that from here. So there is this revolute joint right there. So we can take that and take the minimum and maximum angles from there. So this is minimum -22, like up to here, maybe -20 to +20. So we want to go to minimum and select minimum, and then go to maximum and select maximum. Now let's make that -20 to +20. Hit OK. So what it'll do is it will limit this movement, that way it's not coming out of that housing. All right, look at that. Although the button was not there, we have other tools to work around, and then that's the beauty of this assembly workbench. My friends, I hope you enjoyed this process. If you have any question, comment or suggestion on this model or the last video that I built, please let me know in the comment section below. And also any other questions related to FreeCAD, what other contents you would like to be on this channel, feel free to speak your mind in the comment section. I appreciate those comments, and thank you for watching. I'll see you next time.